All right, in the last three discussions we've talked about just the basic tools: present value, future value, rate of return, number of periods, etc. Then we applied those to bonds. A bond turned out to be a combination of an annuity and the lump sum present value of those two things. And last time we talked about stocks. This time we're going to talk about net present value and the other investment rules that sometimes appear. And the point, just to get to the punchline, the point is going to be that net present value is the decision rule that we prefer to use. So the key concepts, we will discuss payback and discounted payback and understand their shortcomings. So we'll talk about accounting rate of return. We'll talk about the internal rate of return and the profitability index, and how to compute the net present value and understand why it's the best decision criteria. Chapter is outlined as shown here. Okay, why use net present value? Basically, there are three things we want a decision criteria to do. The first is to use all of the cash flows. The second is to use cash flows actually, not net income or other kinds of accounting measures. And the third is to discount the cash flows properly. In other words, deal with the time value of money. And it turns out that net present value does all of these things. It uses cash flows, it uses all of them, and it discounts them. There is a reinvestment assumption. The net present value rule assumes that all cash flows can be reinvested at the discount rate. The net present value rule is this. We will, first of all, what is net present value? It's the total present value of future cash flows minus the cost, or we say plus the initial investment, where we understand the initial investment is a negative cash flow or a cost. In order to estimate net present value then, the first thing we have to do is know exactly how large the cash flows are and when they're going to occur. We have to have an appropriate discount rate, and we also have to know what the initial project will cost us. The minimum acceptance criteria is to accept if the net present value is positive. And if we have to rank projects, we would choose the highest net present value, rank them from highest to lowest, and just go down the list. As far as calculating net present value with spreadsheets, we have an example here. There is a net present value function, and I want to make a clear distinction between the net present value function and net present value. Net present value in this chapter is the present value of future cash flows minus the cost. Net present value is a function that finds the present value of future cash flows from cash flow 1 on. It does not subtract the cost. Let's take a look at this spreadsheet example and we'll see exactly how this works. So I think we have an example here of a right way and a wrong way to do things. The cash flows have been laid out in a row. Cash flow at time 0, the initial cost would be $165,000. Then at time 1 we get $63,120. At time 2, $70,800, and at time 3, $91,080. The required rate of return is 12%. So we've identified the cash flows, we've identified where they occur, we've identified the initial cost, and we've identified a discount rate. Now this is the incorrect way to do things. So if I just push this, you'll see what they've done here is they've put the discount rate in, B4, there's the 0.12%, or 0.12, 12%, and then they've put the cash flows B2 through E2. Now what's wrong with this? Well, net present value function, this net present value function on Excel, wants to believe that the very first cash flow it sees going from left to right or from top to bottom is the cash flow at time 1. So this net present value function is actually finding the present value of some cash flows where the first cash flow at time 1 is minus $165,000, the cash flow at time 2 is $63,120, this is the cash flow at time 3, this is the cash flow at time 4. That's just wrong. Those aren't the cash flows. So we end up with this incorrect answer. Now this is going to turn out to be the right way to do things. Since the net present value function thinks that the first cash flow is cash flow 1, we want to make sure that the first cash flow actually is cash flow 1. So we highlight C2 through E2, and that means that the net present value says, well, that's cash flow 1, that's cash flow 2, that's cash flow 3. Now, how do we subtract the initial cost? Well, it's already a negative number, so we add it outside of the net present value function. So this is the present value of cash flow 1, 2, and 3 minus the initial cost, and that is the net present value. But just don't get confused. Notice that we have here the net present value equals the net present value of cash flow 1, 2, and 3, the function, plus B2. Okay. Let's close this spreadsheet and go back to our PowerPoint slides, move on. Next topic is payback period. Payback is inherently very, very simple. The idea behind payback is how long does it take the project to pay back its initial investment. It's just simply, we don't even worry about the time value of money. We just start adding up cash flows until we get back more cash than we put in. And there's an acceptance criteria, and the acceptance criteria is set by management. So management might, for example, say, we will accept any project with a payback of less than 2 years. Or we will accept any project with a payback of less than 3 years. Each of those would be a possible criteria that a management might establish. As far as ranking projects, that also would be set by management, how management would like to use the payback method to rank different investments. Now, the payback method has some clear disadvantages, and the first and probably most important is that it does something that we absolutely never ever can do in this class, and that is just add up money even though it occurs at different points in time. Remember that dollars at different points in time are not worth the same amount. It also ignores all the cash flows that occur after the payback period. So you can have a project that takes 3 or 4 years and has very low cash flows and then suddenly has a huge cash flow. Well, payback might ignore that huge cash flow and turn out to, here's the bottom line. Payback can reject good projects and it can accept bad projects. Payback is biased against long-term projects. It requires an arbitrary acceptance criteria. There's no reason to think that an arbitrary criteria is economically optimal in any way. And a project accepted based on the payback criteria may not even have a positive net present value. In other words, to say it again, we could actually accept bad projects, projects that will cause us to lose money. The advantages of payback, perhaps why it survives at all, is that it's easy to understand and it's biased toward liquidity. Now, we can get around at least the fact that payback ignores the time value of money by calculating a discounted payback. And what the discounted payback does is first we turn all the cash flows into present values, then we proceed as before. We start adding up cash flows, this time present values of cash flows, and we see how long it takes for these present values to add up to at least as much as we spent on the project, and the amount of time it takes to recover the cost of the project in terms of present value of cash flows is called the discounted payback period. The decision rule, again, is to accept the project if it pays back within a specified time, and the specified time is established by management, and it's somewhat arbitrary and certainly may not lead to optimal decisions. Here's another criticism of discounted payback. By the time you've discounted the cash flows, which you have to do before you calculate discounted payback, you're well on your way to finding net present value. Why not just complete the job, calculate the net present value? Next decision rule or decision tool that's sometimes used is average accounting return. The average accounting return is equal to the average net income of a project divided by the average book value of the investment. It is attractive, perhaps because the data is easy to find, and it seems to be intuitive. It seems to be like a rate of return, and it's really not. But it is fatally flawed. And by fatally flawed, what I mean is you can accept projects that will destroy shareholder wealth, and you can reject projects that would create wealth. So you can make two different kinds of errors. The criteria ranking and the acceptance criteria, again, are set by management. Management might, for example, say, we will accept any project that has an AAR greater than 20%. The average accounting return has some disadvantages. Number one, it ignores the time value of money. It uses an arbitrary benchmark cutoff rate, just as Payback does, and it's based on book values, not cash flows or market values. The advantages of it, probably the thing that makes it most appealing, is that the information is readily available from pro forma income statements and balance sheets, and it's very easy to calculate. Next, and probably the most appealing alternative to net present value, is internal rate of return. An internal rate of return is a discount rate that makes net present value zero. The acceptance criteria is to accept if the internal rate of return exceeds the required return. The required return is usually the cost of borrowed funds. The ranking criteria is to rank these projects, if you have multiple projects, from that with the highest internal rate of return to the project with the lowest, and then work your way down, accept them in the order from highest to lowest. There is a reinvestment assumption. Recall that the reinvestment assumption of net present value was that we can reinvest at the discount rate. The reinvestment assumption of internal rate of return is that all cash flows can be reinvested at the internal rate of return. Disadvantages of internal rate of return, and we're going to talk more about these disadvantages. It does not distinguish between investing and borrowing. Now clearly, if you're investing in a project, your goal is to get a high rate of return, and if you're borrowing, your goal is to get a low rate of return. So it's important to understand whether you're making an investment or taking out a loan. Unfortunately, internal rate of return just gives you a rate. It doesn't tell you whether you're borrowing or lending. So if you just sort of go around the world saying, well, whenever the internal rate of return is high, I'll take the project, you may actually be accepting borrowing projects with very high costs associated with them. The internal rate of return may actually not exist, or there can be multiple internal rates of return, and we're going to see an example, several examples of projects that have multiple internal rates of return. And it can lead to problems with mutually exclusive investments. And by mutually exclusive, what I mean is, if you take project A, you exclude B, and if you take B, you exclude A. The advantage of internal rate of return is that it seems to be easy to understand and communicate. Now, probably the best example of internal rate of return that we have encountered so far, aside from the rate of return on a loan or something like that, is the yield to maturity on a bond. The yield to maturity on a bond, that is the discount rate that makes the price of the bond equal to the present value of its future cash flows. That yield to maturity is an internal rate of return. Here's an example, a very simple example. We have a project. We invest $200 at time 0. At time 1 we get 50 back, at time 2 100, and at time 3 150. The internal rate of the return of the project is 19.44%, and it's found by solving that problem. In other words, the present value of the cash flows minus the cost is equal to 0. And that internal rate of return, whatever it is, in this case 19.44%, makes that thing add up to 0. That is the internal rate of return. We can actually find the net present value of a project at different rates, different discount rates. And if we did that and we plotted them, you see each little box represents the net present value at a different discount rate. And you can see a couple of things. First of all, notice that as the discount rate gets larger, the net present value gets smaller. The net present value below this is the internal rate of return right here. That's the rate right there. The net present value is 0. And anything to the left of that, this project will have a positive rate of return. If we use any discount rate bigger than 19.44%, to the right, this project will have a negative net present value. And you can see that somewhere between 16% and 20%, we turn from positive to negative, and that somewhere where we actually hit zero is 19.44%. Calculating internal rate of return with a spreadsheet, the first thing you do obviously is just put the cash flows in. I normally put them in a column, but you can put them in a row as well. And then you use a function called IRR. Now IRR is similar to NPV. It's a spreadsheet function, but the difference is that IRR lets you put in cash flow zero and NPV does not. So you enter your range of cash flows beginning with cash flow zero. And you can, but you don't have to, you can put in a guess. In other words, you can tell the computer where you want it to start looking. What value do you think, where do you think the rate of return is? The default format, in fact, all on Excel, every return function, whether it's rate or internal rate of return, it will always return a whole decimal place, whole percent. So if you want to see some decimal places, you need to actually look at more decimal places. Here's another example, same example actually. Notice that we have the same cash flows 0, 1, 2, and 3. Now to calculate internal rate of return, let's just take a look at this function. All we do is just take equals IRR, and in parentheses we put the cash flows B2 through E2. And out will come an answer. Now the default format is a whole percent. So this thing is going to tell you 16%. But it's a good idea to take a look at a few more decimal places, and what you see is that this is actually 16.13%. You will, your homework will ask you for the internal rate of return to a couple of decimal places, and you want to make sure that you, when you do that, I'm going to make this bigger so you can just see it for a minute. We want to make sure when you do that you actually look at a few more decimal places and don't just grab 16%. Okay, let's keep going here. Some problems with internal rate of return. I already listed some. First of all, there can be multiple internal rates of return. Now why is that a problem? Well, if there is more than one internal rate of return, and you're trying to use internal rate of return to make a decision, the question immediately arises, which one of these should I use in making my decision? Next problem, are we borrowing or lending? And I've already talked about that. Then we have the scale problem, and I'll show you an example of that. And the timing problem, I'll show you that. I have some examples of each of these.
Mutually exclusive projects are projects in which one of only several of the potential projects can be chosen. For example, acquiring a new accounting system. The basic approach here is to rank all the alternatives and select the best one.
Independent projects, on the other hand, are projects where we can accept every single project that's good. And in this case, all we need to do is make sure that the project has a positive net present value or a positive or an internal rate of return that meets our hurdle rate. Here's an example of multiple internal rates of return. The cash flows minus 200 at time 0, the cost. We get 200 at time 1, we get 800 at time 2. Then at time 3 we have to pay out another 800. There are two internal rates of return here. First is 0% and the other is 100%. And you can see the net present value profile plotted down there. So if the interest rate, if the discount rate is actually negative, we have a negative net present value. Between 0 and 100%, the net present value is positive, and beyond 100%, the net present value is negative. And at 0% and 100%, the net present value is 0. Question, which of these should we use? Should we use 0% in making a decision, or should we use 100%? Well, there really is no good answer. Modified internal rate of return is a way of getting around this problem. What we do is we take all of the negative cash flows, and we call those outflows, and we calculate the net present value of all those using a borrowing rate. And we take all the positive cash flows, which we call inflows, and we calculate them, we move them into the future value using an investment rate. So what we're left with, we clear out the middle and we put everything on one end or the other. All the negatives go at time 0 and all the positives go at the end. And then we just have two cash flows with zeros in between, and we calculate an internal rate of return that makes those two equal. And one of the benefits of that is that we will only end up with a single rate. We won't have this multiple internal rate of return problem anymore. The scale problem is this. Simply put, would you rather make 100% or 50%? Most people would say, oh, I'd rather make 100%. But what if I told you that the 100% is on $1 and the 50% return is on 1,000? What if I further told you that these are mutually exclusive? You either take one or the other. So the question now really is, would you rather have a $1 or $500? And that's an entirely different problem. The timing problem, if we look at two different projects, you can see they both cost $10,000. Project A gives back $10,000 at time 1. So in other words, the big cash flow is at the start of the project. With Project B, we get a big cash flow, but it's at the end of the project. And that's the timing problem. Now, if we look at the net present value profiles of these two projects, A and B, remember, just refresh your memory, A is the front-loaded and B is the back-loaded. This is what they look like. Project A has an internal rate of return of 16.04%. Project B has an internal rate of return of 12.94%. Now, if you were ranking these, you might say, well, I'd take A over B because A has a higher internal rate of return than B does. But notice that these two internal rates of return, these two net present value profiles actually cross. And they cross at 10.55%. Now, if the discount rate is less than 10.55%, then Project B will have a higher net present value than Project A. And Project B would actually be a better project, even though, because it has a higher net present value than A, even though it has the lower internal rate of return. So it's important on the timing issue to understand we're looking at two different projects. Where is the crossover point? The calculation of the crossover point is actually pretty simple. Here we have a little piece of a spreadsheet. We've laid out the project cash flows in columns. Project A in the second column, years in the first, Project B in the third, and in the fourth column we have subtracted B from A. In the fifth column we've subtracted A from B. So for instance, 10,000 minus 10,000 is 0, 10,000 minus 1,000 is 9,000, and 1,000 from 1,000 is 0, and 1,000 minus 12,000 minus 11. If you calculate the internal rate of return of either one of those, and by the way, A minus B is a borrowing project and B minus A is a lending project, if you calculate the internal rate of return of either one of those, you get the same answer. The internal rate of return is, looks like it's around, well, there's the crossover point. Looks like it's 10.55%, and that's exactly what it is. So the internal rate of return of the difference in projects is the crossover point. Now, net present value versus internal rate of return. Generally, they give the same decision. However, when there's a conflict, net present value is the one you should rely on, not internal rate of return. When don't these two give the same answer? Well, if you have non-conventional cash flows, and that means cash flows where the signs change more than once, so that you have multiple internal rates of return, then they won't necessarily give the same answer. If you have mutually exclusive projects, then you won't necessarily get the same answer using NPV and internal rate of return. Remember the two where we had a crossover? if the initial investments are substantially different, or if the timing of the cash flows is substantially different, so that they cross over. Now let's talk about something called profitability index. Profitability index defined to be the total present value of future cash flows divided by the initial investment. Somebody spelled investment wrong. What's the difference between this and net present value? Net present value is total present value of future cash flows minus initial investment. Profitability index is total present value of cash flows divided by initial investment. So the difference, one is subtracted, one is divided. Actually, other than that, they both really give you the same thing. Acceptance criteria, we will accept if the profitability index is greater than 1. Now, if the profitability index is greater than 1, that means that the total present value of the cash flows is bigger than the initial investment, which means the present value of future cash flows minus initial investment is 0, which means the net present value is 0. So, if the profitability index is greater than 1, then the net present value is greater than 0. So they're the same decision. If we're going to rank projects, we will rank them from highest profitability index to lowest. How should you think of profitability index? I've talked to you before about thinking of net present value as a cost-benefit kind of decision. If net present value is positive, it means costs outweigh benefits. You can think of the profitability index as benefits per dollar spent. So you can think of this as like a return on investment, or dollars out per dollar in. Profitability index has some disadvantages. First of all, there are problems with mutually exclusive investments. It may lead you to the wrong investment. The advantages, it probably is useful, sometimes is useful, when available investment funds are limited. In other words, when there's capital rationing. It's fairly easy to understand and communicate, and it leads to a correct decision when evaluating independent projects. Now, what do people actually use? Well, it varies by industry. Some firms use payback, others use accounting rates of return. However, by far, the most frequently used techniques by large corporations are internal rate of return and net present value. And I would argue that if you're going to use internal rate of return for capital budgeting, you need to be very, very careful. Here's an example of two projects. Project A, we put in 200, we take out 200, we take out 800, we put in 800. Project B, we put in 150, we get out 50, then 100, then 150. And the required return on either project is 10%. If we put the cash flows in and calculate the net present value, we can see that the net present value of Project B is bigger than Project A. So, we would accept Project B if these were mutually exclusive. Now, if they're not mutually exclusive, we'll accept both. Both projects are good. As far as internal rate of return, Project A gives us 2 internal rates of return, Project B gives us 1. So in terms of comparing B with A, we really have a quandary here. We don't know which of those 0 or 100% internal rates of return for Project A we should accept. The profitability index for B is higher than A, which suggests to us that if we had to spend some money, we're going to get $1.60 of return for every dollar spent on B, whereas we're only going to get $1.21 of return for every dollar spent on A. So in terms of just ranking the projects, B looks more attractive than A. Payback period, if we look at Project A, we start counting how long does it take us to recover our money. Looks like Project A, it takes 1 year, but wait, it also takes 3 years. So most companies would say, well, it's 1 year, and they would say that's a good payback, we'll take the project. Project B, on the other hand, clearly has 2 years. After 1 year, we have recovered $50. After 2 years, we get the $150. The net present value and internal rate of return relationship, this is easier seen in a graph, I think. Let's take a look and see if we have a picture. There's the net present value profile for project A. Notice the two internal rates of return. And I think here's the net present value profile for project B, and we have one internal rate of return. So there's kind of a picture, and there is a crossover, and anything to the left of that crossover would favor project B. Anything, well, then it gets a little dicey, doesn't it? If we go to the right, we would favor, it looks like project A all the way up to 100%, and then after that we don't want either one of these projects. Okay, just a quick summary of these methods. The net present value is the difference between the market value of cash flows, the present value of cash flows, and the cost. The acceptance criteria is to accept a project if it has a positive net present value, it has no serious problems, and it is the preferred decision criteria. The internal rate of return is an alternative, and a very viable alternative in some cases. It is, by definition, that particular discount rate that makes the net present value zero. We will accept a project if the internal rate of return is greater than the required rate of return, and that presupposes that this is an investment project and not a borrowing project. If you work for a bank, you've got to reverse your thinking on this. It's the same decision as net present value as long as we have conventional cash flows. And by conventional cash flows, I mean cash flows where there's only one sign change. So money goes in, and then from then on out it comes out. The internal rate of return, however, is unreliable with non-conventional cash flows or with mutually exclusive projects. The profitability index we can think of as a benefit to cost ratio. We will take any investment if the profitability index is greater than 1. It cannot be used to rank mutually exclusive projects, but it can be used to rank projects if we have capital rationing. Now there is a caveat to that too. I'll just tell you, I'm not going to emphasize, I don't think your book talks about it much, but if the projects are interrelated so that they occur at different points in time and the cash flows from one facilitate the investment in the next one, then a profitability index probably isn't going to work right. The payback criteria is the length of time until the initial investment is recovered, and we will accept a project if it pays back in some arbitrary specified time, usually established by the management of the company. It does not take into account the time value of money, and the arbitrary cutoff does not ensure that it will make good decisions. The discounted payback period attempts to overcome some of the problems of payback. You first calculate the present value of the cash flows, and then you go through each one until you recover your initial investment. You take the project if it pays back in some, again, specified arbitrary period. And again, the same problem. Now both of these may ignore cash flows that occur after the cutoff, after the payback period. And that can be a real problem. The accounting criteria that we talked about was average accounting return. It's a measure of accounting profit relative to book value. It is similar to return on assets, but it is not really a return, because when you take an average of one thing divided by an average of another, it's not clear what you're taking a return of. You take the investment if the average accounting return exceeds some specified return level, and that specified return is usually arbitrarily established by management. It has serious problems, and by serious problems I mean it can cause you to destroy wealth for the company or overlook wonderful opportunities, and it should not be used. Probably will be, but it shouldn't be. All right, that summarizes, that completes the discussion of the tools we're going to be using. Let's take a look, just kind of walk you through this. Consider an investment that costs $100,000, has a cash inflow of $25,000 every year for 5 years. The required return is 9%. The payback cutoff is 4 years. You should be able to go through and calculate the net present value, the internal rate of return, the payback, and the discounted payback on this project and compare them. So you might want to just try doing that. What's the payback period? What's the discounted payback? What's the net present value? What's the internal rate of return? What you probably can't calculate from this is the average accounting return, because we are not given in this example any book numbers. But the question, should we accept the project, is a thinly disguised question about which of those four methods is best. And the answer is, we should accept the project if the net present value is positive. And so what method should be the primary decision rule? The net present value rule is the one rule we talked about that does not have serious problems associated with it. You can use it in a wide variety of scenarios. When is the IRR rule unreliable? We just talked about those two things. So you should know that. If you don't know the answers to these, if you can't do any of these, answer any of these questions, or you can't answer some of them, you should read the chapter, go back through the slides again, make sure you understand.